Chapter 1. The Binary's Final Waltz. The first anomaly appeared on Dr. Elena Marquez's screen at 2:17 Universal Time Coordinated, May 9, 2043. The Chandra X-ray Observatory's real time feed showed a 300% surge in X-ray emissions from WD 1145 plus 017, a white dwarf orbiting a red dwarf in the Lynx constellation, 12.3 light years from Earth. "Jack, look at this," she said, her voice steady but tinged with the urgency only astronomers recognize. Flux density spiked to 1.2 times 10⁻11 /cm superscript 2/s. That's 3 times the 2042 baseline. Dr. Jack Harper, her colleague and lead astrophysicist at the Goddard Space Flight Center, leaned over her shoulder. The monitor displayed a false color image of the binary system. The white dwarf glowed neon blue, its surface roiling with superheated plasma, while the red dwarf orbited like a dim, rust-colored moon. "Mass accretion rate must have hit critical," he murmured, pulling up historical data. "Remember the 2038 paper by Wachter et al.? When a carbon-rich white dwarf surface density exceeds 109 g/cm superscript 3, runaway fusion ignites." Elena finished. She typed rapidly, referencing with the Hubble Space Telescope's optical data. The system's visible light output had increased by 40% in the past 24 hours, a telltale sign of thermonuclear reactions spreading through the white dwarf's crust. "Core temperatures probably exceeded 6 by 108 K, she said, switching to the thermal model. "This isn't just a flare. This is the beginning of a Type Ia supernova." In the control room, the hum of servers and the occasional beep of alert systems created a tense backdrop. Junior scientists glanced at each other, whispers spreading like wildfire. Everyone knew the implications. A supernova 12 light, years away, was close enough to wreak havoc on Earth's atmosphere, ozone layer, and technological systems. Elena pulled up the binary system's orbital parameters. The white dwarf, at 1.39 solar masses, had been slowly stealing hydrogen and helium from its 0.4 solar mass red dwarf companion for millennia. The Roche lobe overflow had increased exponentially since 2040, pushing the white dwarf past the Chandrasekhar limit. "It's a classic carbon detonation scenario," Jack said, pulling up a simulation from the 2019 Astrophysical Journal. "The entire star will explode within 48 hours, releasing 1044 joules of energy, enough to ionize Earth's upper atmosphere from 12 light years out. The first wave of gamma rays, traveling at the speed of light, would arrive in 12.3 hours. Elena checked the survival probability algorithm she'd helped develop, still at 100%. But that would change once the gamma ray burst hit. "Notify NOAA's Space Weather Prediction Center," she told the technician. "Tell them to activate the ozone depletion models. And get the Navy on the line. Their YLF communication network's about to take a hit." Jack switched to the atmospheric physics module. "Gamma rays will dissociate nitrogen molecules in the stratosphere," he said, projecting a 3D model of Earth's atmosphere. "NOx concentrations will spike to 0.8 parts per million within 30 minutes, catalytically destroying ozone at 1% per minute. The polar ozone layers will be gone in hours, but the real killer is the UV radiation that follows." Elena nodded, her mind racing to the cascade of effects. After the gamma rays came the X-rays, then the far ultraviolet FUV radiation, each layer of the atmosphere under siege. She thought of the 2006 supernova 1994D study, which had shown how even distant supernovae could disrupt Earth's ozone for years. This was no distant event. It was practically in humanity's cosmic backyard. In the observation deck, the Hubble's latest image showed the white dwarf surface erupting in violent plasma jets, each thousands of kilometers long. The red dwarf, now losing mass at an alarming rate, was being stretched into an oblong shape, by the white dwarf's gravity. It's a cosmic suicide pact, Jack said quietly. The white dwarf dies, and it takes its companion and humanity with it. Elena pulled up the global alert system. Governments, space agencies, and research institutions around the world were already receiving the emergency broadcasts. Binary system WD 1145 plus 017 has initiated runaway carbon fusion. Expected supernova in T-minus 47 hours. All personnel activate level 4 space weather protocols. In the lab, a graduate student suddenly shouted, "Optical brightness just doubled. The photosphere is expanding." Elena checked the data. The white dwarf's radius was increasing by 10% per minute, a clear sign that the fusion front was spreading to the star's core. "This is it," she said, her voice calm now, the scientists in her taking over. "The shock wave will accelerate to 0.3 C, releasing gamma rays, X-rays, and FUV radiation in a sequential assault. Earth's atmosphere won't just be damaged, it'll be systematically stripped." Jack nodded, pulling up the satellite deployment schedule. The last remaining geostationary satellites were being repositioned to avoid the initial gamma ray burst, but most would fail within hours. The International Space Station's crew had already begun their emergency descent, a decision made as soon as the first flux anomaly was detected. As the clock ticked down to the supernova's official start, Elena stared at the binary system's live feed. The white dwarf was no longer a point of light, but a seething sphere of fire, its surface convulsing as the fusion front raced through its carbon-rich layers. The red dwarf, now a mere shadow, orbited faster and faster, caught in the white dwarf's final gravitational death grip. "This is what we've been warning about for decades," Jack said, almost himself. A close, range-type I supernova. The perfect storm of radiation and matter ejection, just 12 light years away. No one thought it could happen in our lifetime. Elena didn't respond. She was already deep in the data, calculating the arrival times of each radiation wave, the expected ozone loss, the impact on global communication systems. The survival probability algorithm hadn't updated yet, but she knew what was coming. In 12.3 hours, the first gamma rays would hit, and Earth would begin its dance with destruction. In the control room, the mood was a strange mix of panic and professionalism. Scientists worked furiously, inputting data, cross-checking models, trying to find a flaw in the calculations that would spare them. But Elena knew there was no flaw. The laws of physics were immutable. The binary system had reached the end of its life, and Earth was about to feel the repercussions. As she watched the white dwarf brighten to a level that would soon outshine its galaxy, Elena thought of the millions of years it had taken for this moment. The slow accretion of matter, the gradual buildup of pressure, the final, inevitable explosion. It was a cosmic drama, beautiful in its brutality, and Earth was an unwitting audience member, about to become part of the show. The first alert for the gamma ray burst came at 14:30 Universal Time Coordinated. The sky would remain clear, of course. The gamma rays were invisible, but their effects would be anything but. Elena took a deep breath, steeling herself for what was to come. The binary's final waltz was over, and the real disaster was just beginning. And so, the countdown to Earth's trial by fire began, each second bringing the gamma ray burst closer, each minute eroding the planet's defenses. In the control room, under the glow of 1,000 screens, humanity prepared to face a cosmic storm unlike any it had ever seen, a storm born from the death of a star, 12 light years away. Chapter 2. The Gamma Ray Assault. The first gamma rays hit at 14:30 Universal Time Coordinated, May 10th, 2043. On the surface, nothing visible changed, no flash, no sound, just the same pale blue sky. But in the stratosphere, a silent massacre began. Nitrogen molecules, N2, absorbed the 20-100 MeV photons, dissociating into nitrogen atoms that then reacted with ozone O3, initiating a chain reaction predicted by the 2002 Journal of Geophysical Research model. Ozone depletion rate, 1.2% per minute over the Arctic, Jack reported, his voice tight as he watched the NOAA ozone map turn from blue to mottled purple. Mid-latitudes losing 0.8% per minute. The Antarctic ozone hole, already recovering, just expanded by 300% in 10 minutes. Elena stared at the survival probability tracker. Now at 92%, the first drop. Notify the World Health Organization, she said. Tell them to activate emergency UV shelters. Every exposed human within 48 hours will get third-degree burns. She paused, calculating the numbers. Billions are about to learn what happens when the ozone fails. In the control room, the atmosphere hummed with tension. A technician shouted, "Low-orbit satellite network failing." Starlink 12 to 47 just went dark. Jack pulled up the satellite telemetry. "Single-event upsets in the CMOS chips," he said. "Gamma rays are ionizing the silicon, creating bit flips. The ISS is reporting 500 errors per second in their navigation system." The International Space Station, as predicted, was already in trouble. Their emergency descent had been delayed by a stuck thruster, and now their solar arrays were taking a beating. "Thermal control systems are overheating," came the garbled radio message from the ISS commander. "We're venting oxygen to cool the batteries." ETA to Earth, 90 minutes, but the signal cut off, replaced by static. On the ground, the first casualties of the gamma ray assault were already appearing. In northern Canada, a group of Inuit hunters, caught outdoors, collapsed within minutes, their skin blistering under the invisible radiation. Hospitals in Alaska and Scandinavia activated their radiation wards, but even they didn't have enough lead shielding for the incoming patients. Elena switched to the atmospheric ionization models. The gamma rays were creating a dense layer of free electrons in the ionosphere, disrupting radio communications. AM radio's gone, a communications specialist reported. FM still works, but satellite radio is dead. The Navy's YLF network is showing signal degradation. They're down to 5 kilohertz bandwidth. Jack nodded, recalling the 1967 Carrington event studies. "The ionosphere is like a Swiss cheese," he said. "Every gamma-ray photon knocks an electron loose, and at these flux levels, the D layer's electron density has spiked to 10 to the power of 12 electrons / m superscript 3, 10 times normal." He pulled up a map of global communications. Most of the northern hemisphere was already in radio silence. As the gamma-ray burst continued, the ozone layer continued to erode. By hour 6, the global ozone concentration was down 35%, with polar regions losing over 60%. The UV index, normally peaking at 12 in the tropics, was now off the charts. NOAA sensors maxed out at 35, a level that could cause skin cancer in minutes. In the observation deck, Elena watched as the sun, now unfiltered by ozone, began to leave visible damage. Plants in the Goddard's rooftop garden wilted within hours, their leaves turning brown as chlorophyll molecules broke apart. "It's not just humans," she said. "Every living thing with DNA is under attack." Jack pulled up the agricultural impact projections. Crop models show 100% loss for soybeans and wheat in the first 48 hours, he said. Rice paddies in Southeast Asia are already showing leaf necrosis. The FAO estimates 72% global crop failure by the end of the month. The survival probability tracker dropped to 85% as the first reports of mass animal deaths came in. Birds, unable to navigate due to the disrupted magnetosphere, crashed into buildings. Fish in shallow waters died as their gills were damaged by UV radiation. "The base of the food chain is collapsing," Elena murmured. "Phytoplankton in the ocean, they're dying by the trillion." In the control room, Scientists worked furiously to activate the emergency communication network, a patchwork of old HF radios and satellite phones. "We're establishing a global relay through submarines," a technician reported. "Their YLF antennas can penetrate the ionospheric damage, but data rates are slower than dial-up." Elena nodded, grateful for the 2018 Navy contingency plan that had prepositioned such systems. "Tell them to prioritize medical supplies and radiation shelters," she said. "And get in touch with the Svalbard Seed Vault. Their location might be shielded enough to survive the initial UV blast." Jack, meanwhile, was focused on the long-term atmospheric effects. "The gamma rays have created a surplus of NOx," he said, pulling up a 3D model of the stratosphere. "This will catalytically destroy ozone for years, even after the supernova's radiation stops. We're looking at a 50% ozone deficit for the next decade." The implications were staggering. Without ozone, Earth's surface would be bombarded by deadly UV radiation, making outdoor activity impossible without heavy protection. Agriculture would shift underground, relying on LED lights and hydroponics, but even that would be a Herculean task. As the 6th hour of the gamma-ray assault passed, the first X-rays began to arrive, ionizing the upper atmosphere further. The thermosphere heated to 2000 K, causing the atmosphere to expand. Satellites in low Earth orbit, already damaged by gamma rays, now face increased drag, their orbits decaying rapidly. "Starlink constellation is breaking up," a radar operator reported. "We've got 150 satellites re-entering the atmosphere, creating a firestorm over the Pacific." The images on the screen showed streaks of light as the satellites burned up, a man-made meteor shower caused by the supernova's wrath. On the ground, the first emergency broadcast began to reach the few areas still connected. "This is a level 4 space weather emergency," came the robotic voice of the emergency alert system. "All citizens are advised to remain indoors, seal all windows, and activate emergency UV filters." In the Goddard cafeteria, now converted into a temporary shelter, scientists and staff huddled together, wearing makeshift radiation shields. Elena and Jack joined them, taking a moment to catch their breath. "It's happening faster than the model predicted," Jack said, rubbing his temples. Elena nodded, staring at her portable monitor, which showed the supernova's brightness increasing by the minute. "The white dwarf is burning through its carbon at an exponential rate," she said. "The X-ray and UV waves are going to be worse than we thought. We need to get the underground shelters activated now." Just then, a junior scientist rushed in, her face pale. "Dr. Marquez, the NOAA buoy network is showing something strange," she said. "Ocean surface temperatures are rising, even though the sun's intensity shouldn't be increasing." Elena followed her to the data terminal, Jack close behind. The buoy data showed a 2 degrees Celsius increase in surface temperatures across the North Atlantic in just 6 hours. "It's the UV radiation," she realized. "Water molecules are dissociating, releasing hydrogen and oxygen. The heat from the chemical reaction is warming the ocean surface." Jack pulled up the fluid dynamics model. "This will create atmospheric instability," he said. "Thunderstorms with unprecedented energy, each one a potential supercell." He paused, calculating the numbers. "We're looking at wind speeds exceeding 300 kilometers per hour, with hail the size of golf balls. And that's just the beginning." The survival probability tracker dropped to 80% as the first reports of extreme weather came in. A supercell in Texas produced a mile-wide tornado, destroying everything in its path, while in Japan, freak thunderstorms dropped acid rain, burning through buildings and vegetation. In the control room, the mood was one of grim determination. Scientists knew the worst was yet to come. The gamma rays were just the opening act. Next would be the X-rays, followed by the FUV radiation, each wave more destructive than the last. Elena looked at Jack, seeing exhaustion in his eyes, but also the resolve. "We need to focus on the shelters," she said. "Get as many people underground as possible, the ones who stay on the surface." She didn't need to finish the sentence. Jack nodded, already reaching for the communications console. "I'll coordinate with FEMA," he said. "They're activating the National Underground Railroad, every subway, mine, and bomb shelter in the country. It's our best chance." As the gamma ray assault continued, Elena stared at the live feed from the Hubble telescope, watching the supernova grow in brightness. It was a beautiful, terrible sight, a star dying, taking a planet with it. But even in the face of annihilation, humanity fought on, using every scrap of knowledge and technology to survive, if only for a little longer. And so, the second chapter of the disaster began, each hour bringing new horrors, each minute a test of humanity's resilience. The gamma rays had laid waste to the ozone and disrupted communications, but the real destruction was just starting. The X-rays were coming, and with them, a new wave of destruction that would test the limits of Earth's atmosphere and humanity's will to survive. Chapter 3. The ionization abyss under X-ray storm. 6 hours after the gamma-ray onslaught, the X-ray front arrived. X-ray front detected. A technician's urgent shout jolted Elena from a brief, fitful doze at the console. She straightened up sharply, her eyes fixed on a real, time data screen where numbers dance in a deathly countdown. Energy flux 1.2 times 10-4 erg/cm superscript 2/s. Wavelengths 3 to 10 nanometers. Perfectly matching the theoretical predictions for supernova's X-ray signature. Jack rubbed his bloodshot eyes. The toll of sleeplessness etched deeply on his face, and pulled up the atmospheric model. "Thermosphere temperature has now exceeded 2000 K, he reported, his voice hoarse from exhaustion and tension. "Oxygen molecule dissociation rate is at 67%. At this rate, the upper atmosphere will lose 20% of its mass in 72 hours. We're watching our protective layer vanish before our eyes." Elena switched to the ionosphere monitoring interface, her fingers flying over the keyboard. The green electron density cloud map was rapidly transforming into a vivid red, a visual testament to the chaos unfolding in the upper atmosphere. "D-layer electron concentration has surged to 1012/M3, she said, her tone grim. "AM radio bands are completely paralyzed. Even the Navy's ELF communication is degrading. We're losing contact with submerged submarines as we speak." Suddenly, the control center lights flickered wildly, like a dying star's last gasp, before plunging the room into darkness. Alarms wailed urgently, their shrill tones piercing the air. "Backup power activating." An engineer shouted over the din. "Main grids tripped. Transformers across the eastern seaboard are fried." Elena rushed to the emergency systems console, her heart pounding in her chest. She knew this was no ordinary power outage. The X-ray ionized upper atmosphere was generating intense induction currents, powerful enough to fry transformers and overload power lines. The 2003 solar storm that had paralyzed the Canadian grid was now a mere preview of the global catastrophe unfolding before them. "Activate EMP protection protocols." Jack's voice cut through the chaos. "We've got to safeguard the servers. Our models are the only hope for predicting what comes next." But it was too late. With a loud, sickening bang, the entire control center was engulfed in darkness, only the emergency lights casting a faint, eerie red glow. Elena fumbled for her phone, her hands trembling, only to see "no service" flashing mockingly on the screen. She heard the anxious murmurs of colleagues around her, their shadows shifting uneasily in the dim light. "Stay calm," she shouted, her voice louder than she intended, partly to reassure others and partly to steady her own fraying nerves. This was expected, Initiate manual operation systems. We've rehearsed this. With backup power, several key devices slowly rebooted, their screens flickering back to life. Elena stared at the ionosphere data, a sense of dread pooling in her stomach. X-rays were not only disrupting communications, but accelerating atmospheric escape at an alarming rate. The thermosphere's temperature continued to climb, oxygen ions fleeing Earth's gravity at 1,000 kilometers per second, a one-way trip into the cold vacuum of space. Atmospheric loss rate is now 150,000 tons per day, Jack reported, his eyes fixed on the scrolling numbers. If this continues, the ozone layer will be gone in a week. Every living organism on the surface is a sitting duck for UV radiation. Elena called up the UV radiation prediction model, her jaw tightening. When the ozone layer vanished, ground-level UVB radiation would reach a lethal 120 W/m superscript 2, 40 times normal levels. Alert all surface personnel, she ordered, her voice steady despite the turmoil inside. They must retreat to underground shelters within 24 hours. No exceptions. Hospitals, schools, every public building, convert them now. Just then, the comm system crackled to life, filled with static and desperation. This is International Space Station, requesting emergency descent. Elena grabbed the microphone, her knuckles white. Space Station, this is out of control. Repeat your status. The response was garbled, fragments of words piercing the static. Solar arrays, completely destroyed. Life support systems, failing. Can't hold much longer. Request ground guidance. Jack looked at Elena, his eyes reflecting the same helplessness she felt. Their orbits decaying faster than predicted. They've got 36 hours at most before re-entry. Elena took a deep breath, pulling up what remained of the global positioning system. Most navigation satellites were offline, their circuits fried by the gamma-ray and X-ray assault. GPS signals were intermittent, accuracy reduced to kilometers, useless for precise orbital calculations. Without accurate data, we can't plot a safe descent, she said, frustration edging her voice. Suddenly, a young scientist shouted from across the room, I can track them with the old-phased array radar. It's not perfect, but it's something. Elena nodded sharply. Do it now. Under the intense gaze of everyone in the room, the young scientist operated the radar, his fingers dancing over the controls. Minutes later, he exclaimed, Got him. Stations at 105 degrees west, 40 degrees north, descending at 20 meters per second. But their trajectory is erratic. They're spinning. Jack calculated swiftly, his brow furrowed. At this rate, they'll re-enter in 30 hours. And with that spin, it's a miracle they're still intact. We need a wide, open area, now. Elena's eyes scanned the terrain database, her mind racing. Death Valley, Nevada, she said, pointing to the map. Hundreds of kilometers of empty desert, our best bet. Contact the Air Force. Tell them to launch every drone they have for a guidance corridor. As they planned, the ground suddenly heaved violently, sending everyone stumbling. Elena crashed into the console, her shoulder throbbing. Alarms blared again, merging with the panicked shouts of colleagues. What's happening? She shouted, struggling to stay upright. X-ray, induced geological activity. A geologist shouted back, his face pale. Ionospheric currents are interfering with Earth's magnetic field, triggering quakes across the Ring of Fire and beyond. Elena called up the seismic monitoring map, her eyes widening. From the San Andreas Fault to the Himalayas, from the mid-Atlantic ridge to the East African Rift, the planet's crust was shuddering. A 6.2 magnitude quake struck Southern California, followed by a 5.8 in Japan. This is just the beginning, Jack said, his voice laced with dread. As the atmosphere escapes, The core mantle dynamics will shift further. Earthquakes will become the new normal. The survival probability tracker flashed. 70%. Elena stared at the number, a bitter taste in her mouth. Just 24 hours ago, it was 100%. Now, each percentage drop felt like a nail in humanity's coffin. "Keep working," she shouted, more to herself and others. "We got to secure those shelters. Every life matters." Just then, her personal satellite phone vibrated, a rare connection in the crumbling network. She answered, her hand shaking. "Hello?" A familiar voice, strained but resolute. "Elena, it's Dr. Raj from the Svalbard Seed Vault. We're sealing the doors, radiation spiking. But we got a problem. The cooling systems, they're failing without grid power." Elena's mind raced. The Svalbard Seed Vault, humanity's genetic archive, housed millions of seed samples. If it failed, centuries of agricultural heritage would be lost. Switch to backup generators, now, and use the emergency insulation protocols. We'll send a team as soon as we can. But they both knew there would be no team. Surface travel was becoming suicidal. The call ended with a silent understanding. Returning to the console, Elena met Jack's gaze. "We're losing everything," he said, his voice barely above a whisper. "Not yet," she replied, though she lacked conviction. "Not while we're still breathing." The X-ray storm raged on, each photon a tiny assassin striking at Earth's defenses. In the control center, under the dim glow of emergency lights, they fought on against the odds, against the laws of the universe, against the inevitable. For every second counted, every calculation made, was a defiance of extinction. And as the storm worsened, they knew that even in defeat, humanity's final stand would be written in the stars. Survival probability, 70%. Chapter 4. The FUV onslaught and global despair. As the X-ray storm raged, the countdown to the far ultraviolet FUV radiation arrival loomed. NASA's atmospheric models predicted its onset 18 hours after the X-rays, and at 6 o'clock Universal Time Coordinated May 11th it struck. FUV photons, with energy 6 to 100 eV, began dissociating oxygen, O2, and nitrogen, N2, molecules in the thermosphere at an unprecedented rate. FUV flux at 5 times 10⁻⁸ erg/cm superscript 2/s, Jack reported, his eyes fixed on the Goddard monitors. Thermospheric dissociation rate just spiked to 85%. Oxygen and nitrogen ions are escaping at 1,500 kilometers per second now. Elena nodded, pulling up NOAA's updated ozone map. It was almost entirely purple, indicating a 90% depletion globally. On the surface, the first signs of FUV's wrath emerged. In Death Valley, where the ISS was set to land, temperatures skyrocketed to 75 degrees Celsius, not from solar heat, but from atmospheric friction and FUV-induced chemical reactions. "It's like an oven," a drone operator said, watching feeds from the valley. "Any organic material exposed will carbonize in minutes." The survival probability tracker dropped to 60% as global surface temperatures rose an average of 12 degrees Celsius in hours. The Amazon rainforest, already weakened, began to burn, FUV radiation drying out vegetation to tinder. Satellite images showed vast swathes of green turning to orange and red. Brazil's reporting 100,000+ wildfires, a technician said. No way to fight them. Every firefighting aircraft's grounded due to ionospheric interference. Elena tried reaching the Svalbard vault again. No response. "Their generators must have failed," Jack said quietly. Millions of seed samples gone. But there was no time to mourn. The ISS, now visible on radar, was hurtling toward Death Valley. Deployment of drone guidance corridor. Elena ordered, and pray their heat shields hold. As the station entered the atmosphere, friction with the FUV thin air created a plasma sheath. No radio contact possible. Thermal protection system temperature, 650 degrees Celsius, a radar tech shouted. Above nominal but holding for now. Meanwhile, in major cities, chaos reigned. New York's underground shelters, designed for 500,000, housed 2 million. Riots in Shelter B7. A report came in. Food stocks ran out. People's desperate. Elena sighed, knowing FEMA's contingency plans were overwhelmed. Redirect any available drones for supply drops. Use thermal imaging to avoid UV. Exposed areas. The ISS made its final descent. Parachute deployment in 3, 2, 1. But no parachutes appeared. FUV. Damage release mechanisms failed. Brace for impact. Jack shouted. The station crashed into Death Valley, a fireball visible for hundreds of kilometers. No survivors. Elena turned away, blinking back tears. Update survival probability, 58%, she said. Each loss chipped away at hope, but they had to keep going. Initiate Phase 2 of the atmospheric collapse protocols. Activate all deep underground research facilities, universities, mines, anything with 50-plus meters of overburden. Jack pulled up a map. Only 30% of the population's underground. The rest, he didn't finish. FUV radiation, combined with near-zero ozone, was a death sentence. Skin cancer rates would skyrocket in days, but acute radiation sickness was killing faster. Burns, organ failure. Goddard's going offline in 2 hours. An engineer said, backup generators can't handle the load with FUV. Induce surges. Elena nodded. Transfer all critical data to the Navy's submerged servers. They're our last backup. As they worked, a junior scientist shouted, Hubble's picked up something. The supernova's brightness is increasing again. We're entering the peak radiation phase. Elena checked the data. Flux levels doubling every hour. Notify every remaining shelter. Brace for worse. The FUV onslaught continued, each photon an eraser on Earth's habitability. But in the control center, they fought, logging data, redirecting resources, refusing to let humanity's end be a silent one. Survival probability, 58% and falling, but they calculated, they planned, they defied. Survival probability, 58%. Chapter 5. The Withered Earth. The far ultraviolet FUV radiation continued its relentless onslaught, accelerating Earth's atmospheric erosion at a terrifying pace. NASA's thermal ionosphere models, laboring on the last functional servers, showed the thermosphere losing a staggering 450,000 tons of mass each day. Surface atmospheric pressure has plummeted to 0.7 atm, Jack reported, his voice tight with tension. It's equivalent to being at 5,000 meters altitude. Oxygen saturation in the blood will drop by 25% within minutes for anyone above ground. Acute hypoxia will render most unconscious in under an hour, and there's no escape from this global altitude nightmare. Elena focused on the NOAA weather satellite feed, watching as the planet's weather systems disintegrated into chaos. The jet streams are completely gone, she said. The Sahara is expanding northward at 80 kilometers per day. Dust storms now turn Buenos Aires into a twilight zone, reducing visibility to less than 10 meters. In Shanghai, acid fog has become a constant, eating away at concrete and human lungs alike. Every weather system has become a weapon, and we have no defense. Agricultural models painted a desperate picture. 95% of global croplands faced irreversible UV damage, with wheat and rice yields collapsing by 98%. Even if the UV radiation stopped now, our agricultural infrastructure is annihilated. Famine is a certainty for any survivors. In the Goddard Control Center, the hum of generators grew more erratic. Backup power at 5%. An engineer shouted, his hands raw from desperate attempts to keep the servers operational. Servers are overheating. We're losing critical data. Elena worked frantically to redirect data streams to the Navy's submerged servers, housed in decommissioned nuclear submarines off the coast of Maine. Prioritize the 3D atmospheric collapse model, she ordered. Include the latest ozone profile, 0.005 Dobson units. If anyone ever finds this, they'll know exactly how swiftly we lost our protective layer. Jack intercepted a garbled transmission from the Amundsen Scott South Pole Station. UVC radiation detected at 50 W/M superscript 2, he translated, his face ashen. Their ice core lab is a disaster. Centuries of climate data lost to melting permafrost. The Larsen C ice shelf? Satellite imagery shows 70% calved in 24 hours. Tsunamis are pummeling Chile's coast, but there's no one left to send warnings or mount rescue. Antarctica itself is a radioactive expanse. The survival probability tracker now hovered at 40%. More than 6/10 of humanity is gone, Elena murmured, staring at a FEMA map that was mostly red. Failed shelters, abandoned cities, and silent towns. In the Amazon, drone footage revealed rivers choked with toxic algal blooms, FUV radiation having mutated phytoplankton into a neon green slime. The Congo Basin, once a thriving ecosystem, was now a patchwork of wildfires and scorched earth. Primates huddled in charred trees, their skin blistering and peeling. It's not just humans, Jack said softly. 95% of bird species, 90% of marine life, all gone in a matter of days. The oceans, once teeming with life, are now vast graveyards. Coral reefs, bleached white, collapse into rubble. Fish float belly, up by the millions. As Goddard's lights flickered for the last time, Elena grabbed her emergency kit. To the bunker now, she said. The descent into the 50-meter, deep shelter was a somber procession, each step echoing the finality of their situation. Inside, the air was thick with the smell of damp concrete and fear. Jack tuned the shortwave radio, hoping for any sign of life. Colorado School of Mine Shelter, he said, static crackling in the background. 120 survivors left. No running water. Solar panels fried by FUV. They're drinking melted snow, but radiation has seeped into the groundwater. Many show signs of acute radiation sickness. Vomiting, hair loss, internal bleeding. Another signal, even weaker. Australian Outback Research Station. Desalination plant failed. Saltwater intrusion. Last crops are ash. They're surviving on canned goods, but morale is non-existent. Elena calibrated the bunker's radiation sensors. Surface UVB levels had peaked a staggering 250 W/M superscript 2, a level that would ignite dry wood in seconds. No one could survive above ground for more than 30 seconds, she said, pulling up the last satellite images of the Atlantic. Phytoplankton biomass is down 99%. The ocean's food web is entirely shattered. Whales beach themselves in a final desperate act. Dolphins and sharks float lifeless, their bodies bloated. The seas are silent, devoid of the songs of whales and the darting of fish. Jack pulled up the final image from the Hubble before its systems failed. The supernova, a brilliant white hot remnant, bathed Earth in a glow that was both beautiful and deadly. The planet itself appeared as a pale, sickly blue, its atmosphere a tattered, nearly invisible layer. We were a small, tragic footnote in the universe's history, he said, his voice hollow. Elena shook her head, typing the last entries into the digital logbook. No, we were the universe's experiment. Intelligence born from stardust, fighting to understand its own destruction. Every piece of data we saved, every observation, they're a legacy. Maybe one day, another civilization will find this information. Maybe they'll learn from our mistakes, from our inability to predict and prepare for a threat so vast. We were scientists, observers, until the very end. The bunker's air recycling system wheezed in protest, a reminder of the limited time they had left. Outside, the FUV radiation continued to work, stripping away the last remnants of Earth's atmosphere, heating the thermosphere to a searing 4,500 K. The planet was becoming a world of extremes. Days so hot they could melt metal, nights so cold they could freeze blood, an atmosphere that continued to bleed into the void of space. But in that bunker, two scientists refused to surrender to silence. They documented every aspect of the collapse, each ecological failure, each technological breakdown, each heartbeat of the dying planet. Survival probability, 40% and falling, but their determination to record, to understand, and bear witness burned on. It was a final, defiant act of humanity, an assertion that even in the face of annihilation, knowledge and curiosity endured. Survival probability, 40%. Chapter 6. The Silent Atmosphere. 3 days after the FUV onslaught, the bunker's environmental sensors told a grim story. Surface atmospheric pressure had plummeted to 0.65 atm, equivalent to the peak of Mount Everest. Water will boil at 80 degrees Celsius at this pressure, Jack said, scrolling through the NOAA atmospheric model. Oceans are losing 2% of their volume daily to thermal evaporation. Soon, even underground shelters will struggle to maintain humidity. The hydrological cycle, once Earth's lifeblood, is now a runaway train of evaporation and loss. Elaine had checked the bunker's air quality readout. Oxygen levels at 18.5%, just above the 19.5% threshold for human survival. We need to ration generator use, she said. The air scrubbers can't keep up if we run them 24/7. Outside, the thermosphere raged at 5,000 K, hurling oxygen and nitrogen ions into space at 2,000 kilometers per second. Earth's atmosphere was a leaking balloon, losing 500,000 tons of mass hourly. Each ions escaped a tiny scream into the void, a whisper of Earth's life force draining away. A faint radio signal crackled to life. Australia's Hobart Underground Research Station, one of the few remaining outposts. Our desalination pumps failed. Came the trembling voice of Dr. Li Wei, a veteran hydrologist whose expertise now meant little in a world without water. Salt waters contaminated the aquifer. We got 72 people left, but no drinking water. The children, her voice broke, the unspoken fate hanging heavy. The signal dissolved into static. Jack turned away, jaw clenched. They're gone, he said. No way to survive without fresh water in a radiation-baked world. Even if by some miracle they found water, the UV-laced rain would poison them. The survival probability tracker dropped to 35%. Atmospheric collapse is exponential now, Elena murmured, pulling up the latest NASA simulation. In 48 hours, pressure will hit 0.5 atm, equivalent to Mars. No human can survive surface exposure, even with oxygen tanks. The Bohr effect will collapse oxygen transport in the blood. Hemoglobin won't release oxygen to tissues, leading to cellular suffocation. She recalled the 2010 Journal of Applied Physiology study on high-altitude survival, now obsolete in this new reality. In the bunker's dim light, they reviewed the last satellite imagery from the defunct Terra satellite. The Amazon basin, once a green heart, was a patchwork of gray, desiccated rivers, petrified trees, and cracked earth. The Ganges Delta, submerged under acid rain and rising seawater, had become a toxic swamp. Geological timescales compressed, Jack said, a decade's worth of desertification in days. The Loess Plateau, once a symbol of erosion control, is now a dust bowl, its topsoil gone in minutes under FUV fuel winds. The bunker's motion sensors suddenly blared, minor tremors, for .2 magnitude, centered on the mid-Atlantic ridge. Core mantle interactions are destabilizing, Elena said, referencing the 2016 science paper on atmospheric loss and seismic activity. As the atmosphere thins, the Earth's rotational inertia changes. Expect more quakes, maybe volcanic eruptions. The ring of fire, already tense, will become a chain of destruction. Their last link to the surface, an automated drone deployed from Death Valley, sent back footage. The ISS wreckage, now a fused mass of metal, glowed faintly under 200 W/M superscript 2 of UV radiation. The desert sand, irradiated to glass, sparkled like a field of diamonds. No organic material left, Jack said. Not a blade of grass, not an insect. The surface is a sterilized tomb. Even extremophiles, once thought invincible, are gone. The bacteria in hot springs, the archaea in deserts, no match for 200 W/M superscript 2 of UVB. Elena tried contacting the Svalbard Seed Vault again, though she knew it was hopeless. The last transmission had been 12 hours ago. Generators failed, temperatures rising, seeds are... She closed her eyes, picturing the frozen archives melting, humanity's agricultural heritage turning to mush. All those varieties lost. The heirloom corns, the ancient wheats, gone. Future civilizations, if any, will start from scratch. Remember the 2008 Nature study on cosmic resilience? Jack asked suddenly. They said a Type Ia supernova within 10 light years would sterilize a planet. We were at 12.3. Close enough. He laughed bitterly. Nature's margin of error. 2.3 light years. We lost the cosmic lottery. All our advancements, our art, our science, reduce to footnotes in a universe that doesn't care. The bunker's generator sputtered, then died. Emergency lights flickered on, dim red bulbs casting long shadows. Battery power at 40%, Elena said. We can run the radios for 12 hours, maybe less. Soon, we'll be in total darkness, relying on hand-cranked flashlights. In the silence, Jack pulled out a tattered notebook, his handwritten log. Day 5 since FUV arrival. Global ozone, 0.002 Dobson units. Surface pressure, 0.6 ATM survivor reports. None coherent. We are likely the last functional scientific outpost. Every hour, we're documenting a world that no longer exists. Elena nodded, tracing the outline of Earth on a dusty whiteboard. We should document the final atmospheric composition, she said. Nitrogen, 72% oxygen, 18% carbon dioxide, 9% and rising. The greenhouse effect's reversing. Nights will plunge to 80 degrees Celsius. Days soar to 60 degrees Celsius. A Mars, like dichotomy, but faster. The thermopause, once at 1,000 kilometers, is now at 300 kilometers. Our atmosphere thin, dying skin. Jack added to the board. Humanity's legacy, a species that measured its own extinction in joules and Dobson units. We knew the math, but not the weight of the numbers. We were astronomers, physicists, but in the end, just spectators to our own demise. The bunker's air grew stale, the scrubbers silent. Elena checked her watch. 1,800 hours universal time coordinated. Outside, the supernova will be visible to the naked eye, a second star in the sky, burning Earth's atmosphere like a magnifying glass on ants. Look at it, she said. So beautiful, so deadly. A cosmic paradox. Survival probability, 35%, Jack said, updating the tracker for the last time. Not a statistic, a promise. Each percentage drop a nail in the coffin, but we keep counting. Why? Elena smiled sadly. We're the custodians of the end, she said. No heroes, no miracles. Just two people writing down what the universe did to us. Maybe it matters, maybe not. But it's what we do, observe, record, understand. Even when there's no one left to care. In the darkening bunker, they sat in silence, listening to the distant rumble of earthquakes, Earth's final shudders as it shed its life, giving envelope. The air grew thinner, the lights dimmer, but their notebooks stayed open, pens moving, recording the unrecordable, witnessing the unwitnessable. For in the end, when the last human breath escaped, their data would remain, encoded in submerged servers, etched in radiation-proof drives, a message in a bottle cast into the cosmic ocean. This is how we ended. This is what we saw. And perhaps, for a species yet unborn, it would be enough. Survival probability, 35%. Chapter 7. The final log. 5 days after the FUV onslaught, the bunker sensors recorded surface atmospheric pressure at 0.5 atm, matching Mars' thin veil. Boltzmann escape is now the dominant loss mechanism, Jack said, his voice hoarse from recycled air. He referenced the 2003 Journal of Geophysical Research paper on atmospheric escape, explaining, every oxygen molecule reaches escape velocity within hours of ionization. Earth's atmosphere isn't just leaking. It's evaporating like water on a hot plate. At this rate, in a week, we'll have less than 0.3 atm, uninhabitable even for microbes. Elena checked the bunker's oxygen tank. 15% remaining. At 0.5 atm, even pure O2 won't sustain us long. The partial pressure is too low. She recalled the 1997 Journal Applied Physiology study on low pressure survival. Below 0.4 atm, unaided human survival was minutes. Our scrubbers are barely keeping up. Each breath gets shallower, each heartbeat faster. The bunker's temperature fluctuated wildly, 40 degrees Celsius during day, when the supernova's light hit, plummeting to 60 degrees Celsius at night. No Hadley cells, no heat distribution, Jack noted, pulling up a defunct NOAA model. Thermal inertia's gone. The surface is a thermodynamic nightmare. The Sahara, 80 degrees Celsius by day, 70 degrees Celsius by night. The Arctic, same. No more climate zones, just extremes. Their last satellite link, a military spy satellite, showed the Mississippi River, once a lifeblood, now a cracked mud path. The Himalayas snow-free, baked under 250 W/M superscript 2 of UV. Glaciers gone. Rivers gone. Lakes gone. Elena murmured, updating the log. The Amazon basin is a desert. The Ganges Delta, radioactive salt flats. Ecosystems didn't collapse. They evaporated. Jack attempted one final radio sweep. Any station. This is Goddard Bunker. Do you copy? Static. He tried frequencies from Antarctica to Australia, each channel a graveyard of silence. No response. We're alone. Every other bunker is either out of power or out of people. Survival probability dropped to 30%. Each day, 1% lost mathematical certainty, Jack said, pointing to the NASA derived decay curve. In a week, 23%, but we won't last that long. No air, no power, no hope. The last nuclear plant shut down days ago. Even if they hadn't, cooling systems would have failed. Elena pulled out a faded photo. Her family, pre-supernova. All those lives, all that work, vanished. But why does it matter? We're specks in a galaxy, in a universe that doesn't notice. Jack smiled faintly. Because we noticed. Our data, our logs, they're a bridge. Maybe to another civilization, Another time. We were here. This is what killed us. He tapped the radiation, proof drive storing their work. Every model, every observation, encoded. Even if Earth becomes a dead rock, this drive might survive. Submerged servers, titanium casing, they'll outlast the atmosphere. The bunker's last battery died at 22:17 Universal Time Coordinated. In pitch blackness, they use glow, sticks to right. Day 7, pressure, 0.45 atm02, 12%. Supernova magnitude, 3, visible in daylight. The sun's light now a whisper compared to that inferno. Outside, the thermosphere raged at 6,000 K. Every second, 1 million tons of atmosphere escaped. Neon, helium, oxygen, all gone. The ionosphere, once a radio-reflecting shield, was a ghost. No auroras now, Jack said. No charged particles trapped. All gone to space. Remember the 2012 Astrophysical Journal? Jack asked, nearby supernovae as an extinction mechanism. We scoffed. Now we're its authors. Peer, reviewed by reality. Elena nodded. Science's last act, documenting its own failure. Poetic in a grim way, but better than ignorance. At least we knew why. As the bunker's air grew unbreathable, they lay down, notebooks beside them. Survival probability, 30%, Elena whispered. Not a number, a eulogy. To a planet, to a species, to a dream of forever. In the dark, they close their eyes, listening to the distant hum of Earth's death, atmosphere hissing into space, continents shifting in their final quakes. And though no one would read it, they'd written their legacy. We saw, we measured, we mattered for a moment. Survival probability, 30%. Chapter 8. Epilogue of a Vanished World. 7 days after the FUV onslaught, the bunker's pressure gauge wavered at 0.35 atm, thinner than Mars at its polar winters. Elena gasped for air, her chest heaving with each shallow breath. Partial pressure of O2, 0.055 atm. She wheezed, recalling the 1982 aerospace medicine and biology study. Below 0.06 atm, the human body enters a state of acute hypoxia, where cells begin to suffocate. Cerebral hypoxia, dizziness, confusion onset in minutes. Her vision swam, blurring the edges of the console screen, which displayed a final atmospheric model. Oxygen molecules escaping at 2,500 kilometers per second, a relentless exodus driven by the supernova's FUV radiation. Jack fumbled with a now silent air scrubber, his fingers slipping on the cold metal. No power, he mumbled, voice slurred. The bunker reeked of stale sweat and rising carbon dioxide, a tangible reminder of their failing life support. Every exhale lingered in the air, a fog of defeat. Outside, the thermosphere, now a searing 7,000 K, spewed 1.5 million tons of atmosphere into space hourly, a relentless hemorrhage of nitrogen, oxygen, and argon. Earth's magnetic field, weakened by the loss of ionospheric currents, offered no defense. Solar winds stripped the remnants of the atmosphere like a relentless tide, each ion a tiny casualty in the cosmic war. Elena's thoughts fragmented, drifting to a memory of her first day at Goddard. She'd stood in the control room, awestruck by the vastness of the solar system maps, never imagining she'd one day watch Earth's atmosphere vanish like steam on a mirror. Now, she reached for the radiation, proof drive nestled in a lead-lined box, its surface cool to the touch. Engraved on its titanium casing were the words, "For those who come after, we try to understand." A quote from the 2010 Astrophysical Journal editorial on cosmic legacy. "Our legacy," she whispered, tracing the embossed NASA logo. It held 500 terabytes of data, every atmospheric model, every satellite image, every garbled radio transmission from dying outposts. the Australian mother begging for water, the Chilean scientist describing tsunami waves that would never be survived, the last coherent message from what was once the Svalbard vault before its freezing archives melted. Jack nodded, his eyes heavy with fatigue, but resolute. He recalled the 2015 Nature Geoscience paper on cosmic preservation, which noted that titanium alloy data drives could survive for billions of years in ocean sediments, resistant to radiation, pressure, and time. "They'll find it," he said, voice steady despite the hypoxia. "They'll know a species existed that refused to go quietly, that measured its own end in scientific precision. See this?" He pointed to the drives built in Locator Beacon, a tiny device using radioactive tritium to emit a faint signal for 100 years. Not much, but enough. A breadcrumb in the cosmic dark. The bunker's temperature plummeted to 75 degrees Celsius as night fell, the absence of an atmosphere turning Earth into a celestial refrigerator. Frost formed on the metal walls, then on their breath, crystallizing into delicate patterns before melting in a brief daytime surge to 50 degrees Celsius. Elena stared at the tiny porthole, where the supernova, now a blinding 4.5 magnitude, hung in the sky, its light so intense it cast sharp shadows even through the bunker's thick concrete. Below it, the Earth's surface was a nightmarish landscape. The Amazon basin, once a lush green sea, now a cracked desert glassy sand. The Himalayas, their snow caps evaporated, stood as jagged gray peaks against a purple-tinged sky. "It's beautiful," she murmured, "in a way that kills, like a portrait of a murdered saint." Jack's final task was to update the log, his handwriting shaky but deliberate in the glow of a dying flashlight. Day 7. Surface pressure, 0.35 atm oxygen in bunker, 8%. Thermal cycle, 75 degrees Celsius to 50 degrees Celsius. All external comms failed 12 hours ago. We are the last. The drive is sealed with 500 terabytes of data, NASA atmospheric models, NOAA seismic logs, Hubble supernova imagery, and every survival broadcast from Earth's final days. Coordinates etched on casing. 38.99 degrees north, 77.15 degrees west, Goddard Space Flight Center. May it outlast our fragile breath. As hypoxia tightened its grip, Elena's mind wandered to her mother, last heard coughing in a New York shelter, and to Jack's brother, a marine biologist who'd sent her a final image of bleached coral reefs before the comms died. We were all architects of our own epitaph, she thought, but we built it with equations and satellites, not stone. Jack, meanwhile, found himself recalling a childhood camping trip, staring at stars and wondering if anyone else was out there. Now, he knew the answer, yes, but they'll never meet us. We'll be just another failed experiment in the universe's lab. The end came not with a bang, but with a gradual ebbing. Elena slumped over the console, her head resting on the keyboard. Fingers still curled around the drive. A faint smile played on her lips. She'd always been a pragmatist, but in the end, she took comfort in the knowledge that their data would outlive the atmosphere, outlive the planet, maybe even outlive the sun. Jack's hand lay protectively over hers. His final act one of solidarity, not fear. The bunker, once a symbol of human ingenuity, became their tomb, preserving their bodies in the sub-zero night as Earth's atmosphere continued its relentless escape. Each molecule a tiny flag, waving goodbye to the world they loved. In the weeks that followed, surface pressure dropped to 0.2 atm, then 0.1 atm, nearly a vacuum. The oceans, long since boiled away by thermal evaporation and UV radiation, left behind vast salt flats cracked by extreme temperature swings, their edges lined with calcified remains of marine life. The few remaining volcanoes, their activity destabilized by core mantle shifts, erupted into the empty sky, their ash settling on a planet that no longer had weather to disperse it, creating layers of sediment that would one day tell the story of a world that died in fire and light. But the drive endured. Submerged in the cold, dark waters off the coast of Maine, encased in titanium and lead, it lay undisturbed by the chaos above. Encoded within its memory were the stories of Elena and Jack, of Goddard's last stand, of a planet that had teemed with life for 4.5 billion years. Perhaps, in a million years, a passing probe from a distant civilization would detect its faint tritium signal. Curiosity piqued by the anomalous radiation. Perhaps they decode the data, watching visual records of Earth's green continents and blue oceans, listening to the panicked but precise voices of scientists recording their demise. And maybe, just maybe, they'd learn from humanity's final lesson. In the vastness of the universe, no world is invincible. But to observe, to understand, to record, this is how we defy the void, not with rockets or shields, but with a fragile, flickering light of knowledge. And so, Earth became a silent, airless rock, orbiting a sun that would one day follow the supernova into oblivion. But for a brief, shining moment, two scientists had turned their final hours into a legacy, proving that even in the face of cosmic annihilation, the human spirit, curious, resilient, unyielding, could leave a mark that outlasted the stars. The drive would lie dormant, waiting, a testament to a species that chose to see, to know, and to remember, even as the universe forgot them. Survival probability, 20%. Chapter 9. The Death of a Planet. Days after Elena and Jack's passing, Earth's atmospheric pressure dipped below 0.1 atm, edging toward a near vacuum, without air to scatter light. The sky turned pitch black even in day, the supernova a relentless spotlight burning it, 5 magnitude. Stars, once faint pinpricks, now blaze with unfiltered intensity, their light untouched by atmospheric distortion. The sun, once a life giver, now irradiated the surface with unfiltered UV, X-rays, and gamma rays, stripping molecules from rocks through sputtering, a process normally seen on airless moons, as documented in the 2015 Planetary and Space Science Journal. Each photon chipped away at quartz and feldspar, slowly eroding mountain faces. Geological activity, once tempered by atmospheric pressure, now ran wild. The mid-Atlantic ridge, already stressed, sprouted new fissures. Molten lava, exposed to the vacuum, froze into jagged obsidian spires. Without air, no volcanic gas emissions, recalled Jack's final notes, referencing the 2004 Journal of Volcanology. Volcanoes now erupted in silent, dusty plumes, ash settling instantly without wind to carry it. The Hawaiian Islands, once built by fire eruptions, now saw their volcanoes die not with explosions, but with a whimper, lava oozing then solidifying in strange, angular forms. The oceans, long evaporated, left behind salt basins cracked by thermal stress. The Dead Sea Basin, once a depression, now stretched wider as the crust adjusted to the loss of water's weight. Isostatic rebound. As per the 1999 Geophysical Research Letters, land masses that had sagged under oceanic weight now rose, triggering earthquakes. A 7.8 magnitude quake shook the Himalayas, their peaks crumbling without atmospheric friction to slow rockfalls. Stones that once would have sparked or hissed in air now clattered mutely, bouncing down slopes in a chaotic cascade. Surface temperatures oscillated wildly. At noon, the supernova's FUV-heated exposed rocks to 100 degrees Celsius. At midnight, they plunged to 150 degrees Celsius. This thermal cycling shattered granite into sand, basalt into dust. The Grand Canyon, once a testament to water erosion, now widened as its walls exfoliated layer by layer. Each day, micrometeorites, no longer burned up by atmosphere, pummeled the surface, creating tiny craters. The Gobi Desert, once a sea of sand, became a mosaic of impact pits, each a millimeter deep but countless in number. Cosmic rays, unimpeded by atmosphere, bombarded the surface. NASA's Cosmic Ray Initiative 2020 predicted this molecular level damage to any remaining structure. The Svalbard Vault, its titanium doors warped by heat, leaked melted ice into permafrost, turned desert. The ice, once a reservoir of history, now vanished into the vacuum, leaving behind a hollow shell. Even the hardiest extremophiles, if any had lingered, would have been reduced to molecular fragments, their chemical bonds shattered by high-energy particles. By the end of the first month, pressure hovered at 0.05 atm. The ionosphere, once a shield, was gone. Solar winds etched grooves into the Sahara's glassy dunes, while the Amazon's cracked earth split further, tectonic plates grinding without lubrication from groundwater. The Mississippi River's bed, once a vital artery, now a chasm filled with dust and tiny meteorite debris. Earth, once a blue marble, became a gray ghost. No winds, no waters, no life, just a planet in a death spiral, its atmosphere memory, its legacy locked in a submerged drive. And as the supernova dimmed slightly, Earth's fate was sealed, not with cataclysm, but with the quiet, inevitable march of physics. Each passing hour, another million tons of atmosphere escaped, a slow-motion exodus into the void. The planet, once teeming with life, now a silent observer of its own demise, a testament to the raw power of cosmic events over the delicate balance of planetary ecosystems. Every rock, every grain of sand, bore witness to a world that had danced with life for billions of years, now reduced to a relic of cosmic indifference. Survival probability, 10%. Chapter 10. The Eternal Observer. 50 years after the FUV onslaught, Earth's atmospheric pressure stabilized at 0.01 atm. Thinner than Mercury's exosphere, a near-perfect vacuum where gas molecules rarely collided. The thermosphere, once a seething layer of superheated ions, had dissipated into space, leaving the planet unprotected against the full fury of cosmic radiation. The sky, now a perpetually star, speckled black even during the day, displayed the supernova as a faint white, its brilliance dimmed by distance and time. Without atmospheric drag, the few remaining artificial satellites, including the ruined ISS, now a twisted hulk of metal, orbited with relentless precision, their trajectories unchanged by the absence of air. The Hubble Space Telescope, its mirrors cracked and solar panels tattered, drifted silently, a dead sentinel in Earth's upper orbit. On the surface, human infrastructure told a story of slow, inevitable decay. Steel skyscrapers, once symbols of human ambition, succumbed to thermal cycling. Daytimes heated to 120 degrees Celsius by the supernova's residual FUV. Nights plummeted to 160 degrees Celsius, causing metal to expand and contract until worlds' fractured beams buckled and entire structures collapsed in slow-motion avalanches of debris. Concrete, that most enduring of materials, fared no better. Cosmic rays, unimpeded by atmosphere, bombarded its surface, causing spalling. Layers of cement matrix flaked off, revealing pitted interiors that crumbled into powdery silica over decades. Glass, once a common building material, shattered into microscopic shards under repeated micrometeorite impacts, turning urban wastelands into fields of glittering dust. Plastic, once an enduring pollutant, now fragmented into even smaller particles, each strike from space wearing it down atom by atom. The data drive, submerged off the coast of Maine in what was once the Atlantic Ocean, now rested within a vast salt pan, a fossilized remnant of the sea's evaporation. Encased in titanium alloy rated for 11,000 meters of water pressure, it had survived the ocean's disappearance, now entombed in layers of sodium chloride and calcium sulfate deposited by the final drying brines. Its tritium beacon, half decayed, still emitted a faint beta radiation signal, a tiny pulse every 12.3 years, a temporal marker for any future observer. though none would come. The drive's internal memory, constructed with radiation-hardened flash chips, resisted the slow degradation of electrons in its cells, preserving 500 terabytes of data, atmospheric models, seismic logs, and the final voices of a dying species. At a microscopic level, the titanium casing showed minuscule signs of stress from millennia of geological pressure, yet its integrity held firm, a testament to human engineering's last hurrah. Geological activity had ground to a halt. The Earth's mantle, no longer lubricated by water or influenced by atmospheric pressure, cooled and solidified. The last volcanic eruptions, silent and dusty, had ceased 20 years prior, leaving behind frozen lava flows that resembled shattered black glass. The tectonic plates, once in constant motion, now lay dormant, their boundaries sealed by mineral deposits. Even the planet's rotation had adjusted. Without the angular momentum of substantial atmosphere, Earth's day lengthened by 0.0001 seconds per year, a subtle change recorded in the fossilized layers of its crust, as predicted by the 2018 Journal of Geophysical Research on Planetary Mass Loss. Over time, the absence of atmospheric mass also affected the Earth's gravitational field, though minutely, altering the subtle balance of its orbit ever so slightly. The surface itself had been transformed into a lunar-like landscape, though far more sterile. Micrometeorites, millions of tiny space rocks, each no larger than a grain of sand, bombarded the planet without resistance, creating a carpet of impact craters. The Sahara, once a sea of golden dunes, was now a smooth plain of vitrified silica, its surface melted and solidified by the heat of countless micrometeorite impacts, glinting dully under the supernova's light. The Amazon basin, a network of cracked earth in Elena and Jack's time, had fractured further, its tectonic stresses released in a final series of earthquakes that split the continent into jagged, motionless fragments. Quartz in the rocks, under constant cosmic ray bombardment, began to amorphize, its crystalline structure breaking down into a disordered state, a process observed in lunar samples returned by Apollo missions. In the bunker beneath Goddard Space Flight Center, the bodies of Elena and Jack remained preserved by the cold, airless environment. Elena's hand still clutched the data drive, her fingers curled around its casing, now slightly corroded by the salt water that had seeped in during the ocean's final days. Jack's arm rested across her shoulders, his lab coat tattered but intact, its fabric degraded at the molecular level by decades of cosmic radiation. They lay not as corpses, but as frozen silhouettes, a final testament to human perseverance in the face of annihilation. Their DNA, once a blueprint for life, now slowly uncoiled under the assault of ionizing radiation, each strand breaking at the bonds that once held the promise of continuation. Earth continued its orbit, a dead planet in a quiet corner of the Milky Way. The sun, still a yellow dwarf, shone unchangingly, unaware of the drama that had unfolded on its third rock. The supernova, now a white dwarf, faded further, its energy spent, leaving behind a legacy of destruction that had unfolded over decades. No aliens would visit, no probes would arrive, just a slow march of time, erasing even the most stubborn traces of human existence. Yet the data drive endured, buried beneath meters of salt and sediment, its titanium casing resisting the relentless pressure of geological time. It held within it the sum of humanity's final observations. The precise moment atmospheric pressure dropped below survivable levels, the last coordinates of dying outposts, the wavelength of the supernova's fatal radiation. It was not a message to the stars, but a record for the void, a proof that, for a brief, glorious interval, a species had existed that dared to measure the universe, even as the universe rendered it obsolete. And so Earth orbited on, a silent monument to the fragility of life in the cosmos. No wind would ever again whisper through its canyons. No rain would ever again carve its mountains. No voice would ever again speak its name. But in the cold, dark depths of a long, dried sea, a small metal box held the story of a world that had burned brightly, if only for a moment, before slipping into eternal silence. As eons passed, the data drive would endure, a solitary fragment of meaning in a universe that cared not for its tale, yet allowed it to persist, an eternal observer of a planet's death and a species' fleeting moment of light. Survival probability, 0%.